Section 5.1 Systems of Linear Equations. First, let's talk about what is a system of equation. System of equation is a two or more equation with two or more variables. And then they do have a common solution. So look at this example. We do have two equation and two variables. And this is a three equation and three variables. They do have the common solution. Identifying solutions. A solution of a system of two equations in two variables is an ordered pair of numbers that makes both equations true. So for example, I do have an ordered pair. If this is the solution of this system of the equation, when you plug into both of the equation, you're going to get the true statement. Example 1. Determine whether 1, 5 is the solution of the system. So what we're going to do, we're going to plug in the solution into the first equation. X equal to 1 and then y equal to 5. So this is good. We got the true statement. And then second equation, do the same thing. We're going to plug in 1 and 5 into the second equation. So 7 equal to 7. So this is true. So we know that this ordered pair is a solution of the system. When one equation in a system can be obtained by multiplying both sides of another equation by a constant, the two equations are said to be dependent. If two equations are not dependent, they say to be independent. Solving system graphically. One way to solve a system of two equations is to graph both equations and identify any points of intersection. The coordinates of each point of intersection will present a solution of that system. So the first method, solve by graphing. Okay, for example, I have a two equation, two variables, and let's try to plug in the points to graph these two equations. So first one, when x equal to 0, y will be equal to -1. Second, x equal to 1, y will be equal to 0. Okay, and then you should get this. Now the second equation, when x equal to 0, y equal to 5, x equal to 3, y equal to 2. When x equal to 5, y will be equal to 0. Okay, let's graph these two equations and then write down the name, okay? Now, we're going to find a one intersection point, and this point will be 3 and 2. So we say that 3 and 2 will be the solution of this system. So if we plug in back this solution onto both equations, you're going to get the true statement. And then from this graph, we're going to say the lines intersect. They have a one solution. They have a one intersection point. That means they do have a one solution. The lines intersect and get one intersection point. So we say we have a one solution for this system. And then system is consistent because we can find the solution. So the system is consistent. Equations are independent. Okay, independent. Talking about there are two different equations here. Second one. So this time, we're gonna try to graph with the slope-intercept form. Okay, remember y equal to mx plus b, y equal to mx plus b. And then the m will be the slope and then b will be the intercept. So for this one, the slope will be equal to 2. And then the intercept, the b will be equal to 3. Okay, this is going to be y-intercept. So you should have a 0 and 3 here. Same idea for this guy. Slope equal to 2. Y-intercept will be -1. Okay, so what we're going to do, let's try to graph this equation. B equal to 3. So 1, 2, 3. We do have a point here. And then the slope is going to be equal to 2. Slope will be y over 1. Okay, so it's going to be y 1, 2, and then 1 unit. So we're going to get these two intersection points. Okay, this point and this one. Second one, do the same thing. B equal to -1, so we're going to start from here. And then m equal to 2, so y is 2 unit and go to the right 1 unit. So we have this point and this point together. Okay, and these two lines, we don't have any intersection points. And we say the lines are parallel. When the lines are parallel, the system has no solution because they don't have any intersection point. Okay, lines are parallel and no solution. The system is inconsistent because we can't find any solution here. And then the equations are independent. This is a two different equations, so the equations are independent. Okay, example 4. I want you guys try plug in the points, graph the equations. Okay, check your work. You should have only one equation here. Okay, when you plug in the points, you're gonna realize these two equations are identical. Okay, both equations give the same line here. Okay, and then there are infinitely many solutions because these two lines are duplicate. So you could imagine all the points on this line will be the solution. And that's why we say this is infinitely many solutions. And the system is consistent because we can find the solution here, right? And then the equations are dependent. They're exactly the same equation. Okay, this is identical. You can try multiply by -2 for the first equation. Okay, -2 times here, you're gonna get -6x. -2 times here, you're gonna get +2y. You times -2 here, you're gonna get +12. So these two lines are identical. And that's why we say equations are dependent. Okay, we summarize for this 3 example. You're gonna see we do have 3 kinds of solution. First one, you're gonna have a 1 intersection point. So you do have a 1 solution. And here, they don't have intersection point. And these two lines are parallel, so no solution. And this one, the last one, you do have an identical equation. So all the points on this line will be the solution. So we call this as infinitely many solutions. And this one, we can find the solution. So system is consistent. And this one, no solution. So system is inconsistent. And last one, we can find the solution. So system is consistent. And then these two are two different equations. So this is equations are independent. These two also, they are parallel to each other, but this is a two different equations. So equations are independent. The last one, they are identical equation. So we say equations are dependent. I need you guys remember all this for the exam, okay? Okay, we can solve the system of equation by graphing. Second one, we're going to use the substitution method. Okay, substitution method. Usually, when we want to use the substitution method, you will have the one equation with isolated variable. Okay, like this guy. Y equal to x minus 1. Okay, we're going to name it. This is an equation 1. This is an equation 2. And then we're going to plug in the equation 2 into the equation 1. We're going to substitute the y with x minus 1 here. Okay, your y will be equal to x minus 1. And then now we only have a one variable for this equation. So we're going to solve for the x. You're going to get x equal to 3 over 2. Once you're done, plug in back to the equation 2 and then solve for your y here. You should get y equal to 1/2. And then at last, y your solution has an ordered pair. Okay, 3 over 2 and 1/2. We also can check our work by substitute the ordered pair into the original pair of the equation to check if this is the solutions. And then since after we use the substitution, we find one ordered pair. This is going to be one solution. And the system is consistent. And equations are independent. Okay, example 6. Solve the system. So first, let's name the equations. And then we want to use the substitution. So usually we're gonna choose the variable with the coefficient of 1, okay, positive 1 or negative 1. So we have a 3x, 2x, 1y, 3y. So we're going to use this variable. Okay, so we're gonna isolate the variable of y. So y equal to 5 minus 3x. And then we're gonna substitute to the equation 2. Okay, we started from the equation 1. After we isolate the variable of y, we're gonna plug in back to the equation 2. Okay, so my y will be equal to 5 minus 3x. Distribute it one by one. Make sure you distribute the negative as well. Combine the 9 terms. You're gonna find x equal to 2. Okay, now we're gonna plug in back to this equation. Find out what is your y. You should get y equal to negative 1. Okay, so the ordered pair 2 and negative 1 will be the solution for the system. And again, we do have a one solution and the system is consistent. Equations are independent. Okay, another one. Both of them has the x here. So we could use the substitution, make it like equation 1 equal to equation 2. Okay, simplify. Combine the 9 terms. You're gonna get 2 equal to 5. And then this is a false statement, right? 2 is not equal to 5. When we get the false statement, that means the system has no solution. So think about it. We do have a 3 case, right? The first one is gonna be you do have a one intersection point. Second one, when the lines are parallel, so there are no solution. So now we find the system has no solution. That means the lines are parallel. And the system is inconsistent because we can't find the solution. And the equations are independent. There are 2 different equations here. Okay, the last method, elimination method. The elimination method for solving system of the equation makes use of the addition principle. If A equal to B, then you're gonna add C for both sides. They are still equal to each other. Okay, I have these 2 equations here. Okay, x and the negative x. Elimination is we try to add up the equation and eliminate one of the variable. So for this example, I have a one positive, one negative. When I added up these 2 equations, added up, right? 0x, that will be 0. And then you only have a 2y equal to 14. Divided by 2 for both sides, you're going to get y equal to 7. Okay, once you find out one of the variable, you could put it back into either one of the equation. Okay, I'm going to put it back to the equation 1. When y equal to 7, so x going to be negative 2. So again, we get the order pair, negative 2 and 7. And this is going to be one intersection point, so one solution. System is consistent and equations are independent. Okay, example 9. Since we have the fraction for this equation 2, okay, we want to get out of the fraction. So think about it. What is the LCD for the second equation? LCD will be 12, right? So what we're gonna do? We're gonna multiply 12 for the whole equation. Okay, times 12. Simplify it. So 12 divided by 4, you're gonna get 3x. 3x plus 4y equal to 12. Okay, now we want to solve these two equations, the 3x plus 4y equal to 12 and the first equation. Okay, I put it together. And then we want to use the elimination method. But when I add it up, I'm going to get 4x here. And this is going to be 2y. So even though I add up these two equations, I can't eliminate the variable. So what we're going to do? We're going to use the first equation, multiply by 2. Okay, you're going to times 2 for the whole equation. So you're going to get 2x minus 4y equal to negative 12. And then we still have the equation 3 here. Now, we could add it up together. So you're going to get 5x equal to 0. So x equal to 0. Okay, now after we find it out the x, we could put it back to the equation 3 here. When x equal to 0, you're gonna get y equal to 3. So one more time, we're gonna get the order pair, 0 and 3. So we have a one solution, system is consistent, and equations are independent. Okay, example 10. So same idea, we want to use the elimination method. So we're gonna multiply by 2 for the first equation. Okay, so you're gonna get this. And then the second equation will be here. Okay, add it up to see what happened. You're gonna get 0 equal to 0. And this is gonna be the true statement. Okay, remember we do have a free case. Case 1, when you have a one intersection point, so you do have a one solution. Case 2, when two lines are parallel, they never intersect on each other, so there'll be no solution. Case 3, when two equations are identical, okay, so there will be infinitely many solutions. Okay, infinitely many solutions because identical equation. And system is consistent because we can find the solution. And the equations are dependent because this is the identical equation. Okay, try this one. For this example, I'm gonna multiply 2 by the first equation. Okay, times 2 here. And then the second equation, I'm gonna times negative 3. Okay, second equation, I'm gonna times negative 3. So you should get this guy. And I call this as an equation 4. Now I'm gonna add it up, equation 3 and equation 4 together. So you're gonna get zero equal to 21. And this is a false statement. Remember that when you get the false statement, what kind of the solution is it? That would be no solution, right? Because lines are parallel. And the system is inconsistent. And equations are independent. Okay, after the substitution and elimination method, we summarize it again. When you get the ordered pair, the xy, we have a one solution, system consistent, and equation are independent. But when you get the contradiction, like when you get the false statement, such as 0 equal to 7, then no solution, system is inconsistent, and equation are independent. When you get a true statement, okay, 0 equal to 0, like that, that means you do have an infinitely many solutions. System is consistent. Equation are dependent because this is the identical equations. Okay, identifying solutions. A linear equation in 3 variables is an equation equivalent to 1 in the form ax plus by plus z equal to d, where a, b, c, and d are real numbers. We refer to the form ax plus by plus z equal to d has a standard form for a linear equation in 3 variables. When we have a two equation, two variable, you could consider this is going to be a straight line, a linear equation. But when you have a three equation, three variables, you could consider that would be a plane. Okay, this is going to be a plane. When you're solving the system in 3 variables, at the beginning we were using the elimination method. Okay, we try to eliminate one of the variable. Okay, make it like 2 equation. And then once you solve one of the variable, we can use the substitution method. Okay, let's look at this example. We could select any 2 of the 3 equations and work to get one equation in 2 variables. Let's add the equation 1 and 2 together. Okay, when we add it up, we should get out of the variable of z. Okay, add it up. Now we have a 2x plus 3y equal to 8. And then we're gonna add up 2 and 3 together and try to eliminate the variable of c here. Okay. But you could see when I add it up, I still have a 2z here. So what we're gonna do? We're gonna multiply by 3 for the second equation. Okay, times 3. And then equation 3, I just write it down one more time. And then add it up together. You're gonna get 4x plus 5y equal to 14. So you do have a 2 linear equation with 2 variables. Okay, let's take care of these 2 equations. Okay, we're gonna multiply both sides of the equation 4 by -2. Okay, we're gonna times -2 here. So you're gonna get this guy. And then we could add it up with the equation 5. Okay, add up this equation. So you should get -y equal to -2, means y equal to 2. Okay, once you find out the y, you could put it back either one of the equation to find out the x. Simplify it, you're gonna get x equal to 1. Okay, once you're done, you get x equal to 1, y equal to 2. You're gonna put it back into the original equation. Okay, either one of them. I'm gonna put it in the equation 1. So I know x equal to 1, y equal to 2. And then I'm gonna get z equal to 3 here. So we do have the order triple 1, 2, 3. Okay, it should check in all three equations. So in this part, I only have a one solution, and the system is consistent. Equations are independent. And again, when you have a free equation, free variables, this is talking about the plane equation, okay, the plane. So the picture is gonna be looks like that. When we find one intersection point, the picture is gonna be looks like that. I have a first equation, second equation, and then the third equation. I only have intersect one point. Or when this free paper intersect with a line here, this is called infinitely number of solutions. And all free paper is going to be parallel to each other. They don't have the intersection point. So this is a no solution. Or they intersect like this way. Okay, so this is called no solution also. Okay, try this example. I do have first equation, that's a no variable of x. So we could try to combine 2 and 3 together, eliminate the variable of x here. So try add it up. You're gonna get y plus 2z equal to 6. Okay, now we try to eliminate the variable with the equation 1 here. Okay, we're gonna multiply -1 for the first equation. And then we're gonna add it up together. We got 0 equal to 4. And this is gonna be false statement. So we know this is gonna be no solution. And the system is inconsistent. That's it.